Hello, welcome back to Radical Square Roots in Algebra. We're inching our way forward. Now we're talking about square roots. Later we'll be talking about cube roots and higher order radicals, and then we'll be solving equations with radicals and so on. Here is part 2 of simplifying square roots with using these things called factor trees. Now we've got the basic preliminary ideas out of the way from the last lesson. We'll just crank through a bunch of additional problems to continue to solidify your skills. Now, what if you have the negative square root of 16? Now, a lot of students think this is a trick question because in the last lesson I told you over and over again, if you take the square root of a negative number, like negative underneath the radical symbol, you don't get a real answer. There's no way to multiply something times itself to give you a negative number. It's not possible. So they see this with a negative on the outside and they think something's up. Well, this is not anything other than sort of a trick question. What you have is a negative times, negative 1 times the square root of 16. But you know with the square root of 16, if you do a factor tree, it'll be 4 times 4. It'll only come out once. And so the answer is going to be the negative sign right there, negative 4. So the answer is negative 4. Because the negative sign was never underneath this radical at all. It was on the outside. So it just comes along for the ride. You simplify this to 4, and so the answer that you get is negative 4. Now, as a contrast to that, if I had that square root of negative 16 where it was underneath the radical, there's no real answer there. No real answer. And that's what you would write down. Now, we'll learn later, again, we'll talk about complex numbers, imaginary numbers, and we're going to deal with that later. But for now, we just say there's no real answer. All right? Let's take another one. What if we have the square root of 81? Well, what do? What times what gives us 81? 9 times 9 gives us 81. We have a nice perfect square. We circle it, but it only counts one time when we pull it out. So the answer is 9, because 9 times 9 is 81. Now, what if instead of square root of 81, we had the negative square root of 81? Right? Well, the 81 is still handled the same way. 9 times 9, you circle this. The negative sign was never underneath to begin with. So the answer that you get here is negative 9. Because the negative gets multiplied times whatever this is, which just so happens to be 9. I'm doing this with negatives because a lot of students get confused. If the negative's outside, the negative's inside, whatever. This is just negative 1 times whatever this comes out to be. So it becomes negative 9. Right? So what you're really worried about is if you have the square root of negative 81 in here. And this one is not real. Because there's nothing times nothing that will ever give me this 81, like this. All right, moving right along. What if we have something else? Instead of just a number under the radical, what if we have 7 squared and we put that under a radical? What do we have there? Well, you can do it a lot of different ways. You can, in the next step, you can say it's 49 because 7 times 7 is 49, or you can just do your factor tree right from here. 7 squared, by definition, means that it's 7 times 7. You don't even have to know that this is 49. If it's squared, it is, by definition, times itself. So then you can just say, well, I have a nice pair here. I can stop my factor tree. It comes out one time, and the answer is 7. So notice what's happened here. The square cancels with the square root. They kind of annihilate each other, and what you get back is what's on the inside. But also notice that this was a positive number to begin with here on the inside. So the positive answer we get is perfectly fine. You only run into problems, I think I mentioned it in the last lesson, we're going to talk about it a little more as we get to the end of the problems here, is if you have quantities under the radical that are squared, but they're negative quantities. The square and the square root still cancel, but you have to basically treat it as the absolute value of the answer. In this case, it was positive to begin with, so getting a positive 7 is fine. But just as I guess we'll just do it as an aside. Why not? Let's just do it since I'm talking about it. We talked about this in the last section. What if I have negative 6